the accelerating energy transition. And so there's a few things I want to give you a sense of. So just for a beautiful picture, this is the Altamont wind farm that we go to for that field trip. So you can see you kind of get out there in the wind farm. All right, so today we're really going to dive into just briefly where our energy comes from. I want to go into more detail about why we care, and so I'm going to list some things about why we think people care about energy, and so I want you to think about why you care, why you're here to learn about energy. And then we're going to hopefully talk about some of the accelerating energy transitions that are going on. And I say these are exciting because when I was sitting in your seat, it was a very different landscape. People thought coal was going to be the cheapest energy resource forever, and we were going to use coal forever. Solar was never going to be cheap enough. It only had space applications or calculations on calculators and things like that. Wind was just starting to be like, maybe wind will be cost competitive. We are in a very different energy system now, and that's really exciting. Things are changing. There are things that are being driven by our climate, driven by policy, driven by people to make those changes happen. And so it's an exciting time to be learning about our energy industry. Okay, so first, just to give some kind of basic grounding here. What do we mean when we talk about energy? And so this is a map. This is to think about our energy system. And what we humans really care about are services. We want lighting, we want comfort, we want our phones and our computers charged. We want services. That's really what a lot of this is about, right? Is services. And a lot of people just here, they just want their services. Well, to get those services, we use resources. This is what exists to us. And we have to take those resources and transition them into a currency or a secondary energy that allows us to provide those services, right? So this is our energy system. And so yeah, we're going to go through each of these energy resources as our lens for this class, but it really is all about human services. And so one of the things we're going to talk about is efficiency. You always want to start with, what are you going for? What do you want? Why are you there? Because you think, I want lighting. Well, then let's start with daylighting before we start thinking about LEDs or more efficient lighting systems, right? Let's start with what do we have available, right? And so services are really what it is all about. The resources that we have aren't in the form that makes it useful, so we have to do stuff to them in order to get the services that we want. So that's the map that we're thinking about. These are the two largest energy systems in the world today. Oil for transportation, coal for electricity production. These are still the two largest energy systems in the world. And so I put them up here to kind of give you a sense of what that energy system looks like, from our resource to drawing out the resource to converting it to something that's useful. For oil, it's gasoline or diesel. For coal, it's converting it to electricity in order to get it to the technology that's giving us the service that we want to finally get the service that we really want. What do we really want? We want our, in this case, lighting, or we want to be able to move around conveniently. And this is the whole system that provides that. These are very inefficient systems to be able to do that. And so this triangle at the bottom is to give you a sense that we put 100 units of energy resource in at the beginning, we're only getting 1 to 10 units of energy service out. This has to be done in a better way if we want to provide human services to all of us on this planet. We need to do this in a more efficient way. And the challenge is, and kind of the biggest challenge in these systems, is we use heat engines. So we're using heat to provide the power that we need. For coal, that power station is a heat engine. So 2/3 of the energy you put into that coal-fired power plant is lost. It's just lost because it's a steam cycle power plant. It's a heat engine. And so you're already losing a lot of energy just there. For the oil, a lot of that energy is lost in your car. That is also a heat engine. And so again, you're only getting 25, 30% efficient at best in your car, and that's to move your car around, not to move you around. Only about 1% of the energy you put in your car is moving you around. And so these have to change. And so when I say, and I kind of already gave you a preview, that I get excited about electrification, it's a lot more efficient. It's a lot more efficient to move us around by motors than it is by little heat engines in our cars. And so I get excited about the possibilities that efficiency provides, as well as the diversity of resources we can use to provide it. Okay, but more about that later. Okay, so energy systems, we have to do them better. We have to think in terms of systems to think about efficiency. So what does it look like? Fossil fuels are meeting our needs right now. This is what the world energy consumption looks like. 82% provided by fossil fuels. I'll give you a sense of how that percentage has changed over time. Yeah, it's coming down as a percentage, but overall, our energy demand is also going up at the same time. And so that has to come down a lot faster in order to decarbonize on the time scale that we really need to be decarbonizing. And so you can see, this is all energy. I put commercial there because this does not include what we usually categorize as traditional biomass. So much of the world, many of the people in the world still collect their own biomass, whether that's animal waste or trees or other biomass to use for energy. And so about 7% of our final energy consumption is still traditional biomass, people using those types of resources. They're not in these kind of charts. So I remember I said you've got to kind of think about what assumptions they make and what data that is. This data set, which is by the Energy Institute, it's a statistical review of world energy, they're only looking at commercial energy. It's stuff that's bought and sold. And so that is, there's still a huge population that uses energy that's not bought and sold, and it's not included in these charts. So just keep those kind of things in mind as we talk about these things. So that's all energy. If we just look at the subset that's electricity, it's still very much dominated by fossil fuels. That has gotten better. We have a lot of solutions in electricity, wind and solar being big ones that are really taking off. We'll talk about geothermal, hydro. We have other decarbonized systems, nuclear, that we can use in electricity. You can see the big difference between these two pie charts is really that oil wedge. And that's because oil is for transportation. It's a much harder space to decarbonize, is our transportation system. And so that is a huge challenge. And part of that is about energy density. So oil is a very energy dense from both a volume and a weight standpoint. And if you're going to carry around your weight with you in transportation, you want it to be very energy dense, right? And so that is a huge challenge. But as I said, there's lots of things that are happening right now that are trying to tackle that. So it's a really exciting time in our transportation systems. Okay, so that's where we're at. That's what our landscape looks like. And it's been that way for a while now. So if we look back in history, what provided our energy resources? We've been using traditional biomass and wood and things like that for a long time. Really came onto using the coal in the 1900s, early 1900s. And then we discovered the usefulness of oil and gas. And so really in the 50s, 60s, that really started to take off. And so what we're doing now is looking for the future, right? And how do we continue to provide those human services that we want, but not using those fossil fuels that are so damaging to our environment, right? And so that we have to move to a clean energy age. It's just how fast and how do we do it in an equitable way are really some of the big questions of our day. Okay, so that was the world. A lot of time in this class we do the world and then we bring it down to the United States. We bring in other perspectives of other countries when it's relevant to the resource, but obviously we can't cover all countries individually here, but we'll talk about them when it's really important or they're really a leader in a space. But bringing it down to the world, so this is the United States, energy consumption by fuel, looking at it in a little different way, right? So the other way that, charts will tell us different things depending on how we're looking at it. So this is just showing you over time all the different energy resources. And so there's some key things you can see here, right? We've been using wood for a long time, but it's not a growing resource. Hydro since the 1900s, also not a growing resource. You see nuclear take off in the 60s, and we'll talk about nuclear more. And then you see renewable energy really taking off when wind and then solar, a little bit delayed, became competitive in the market. And so a lot of technological innovations in order to get us to this inflection point that is really taking off. You see oil and natural gas really taking off. And we're going to talk about some of the revolutions next week that drove some of the low prices in oil and gas that really made them a big part of our system and really made them desirable fuels. And then you can see coal in the United States really peaked in 2008 and has been on a pretty steady decline since. And so when you hear about politicians saying they're going to save the coal industry, coal has been on a decline for a lot of factors, and it's not really a political challenge at this point. Natural gas, wind, solar are cheaper than existing coal. New resources are cheaper than existing coal, and so that decline, with some ups and downs, is expected to continue in the United States. So you can see like a lot in just this single picture of what's going on in the US. To give you a snapshot, here's what it looks like today for coal, oil, and natural gas in the United States. So again, still very fossil fuel dominated. All right, now this is just looking at the electricity sector only. When I said that's where a lot of our decarbonization has happened so far, is in the electricity sector, giving you a little bit different way of looking at it. So now we're looking at all of the electricity demand and what was meeting that demand. And so I said, when I took this class, it was about 2004 right here. Coal was 50% of our electricity grid and was expected to be 50% forever. And you can see that's because if you look back, it was 50% for a long time. Coal industry was cheap. It was available. We have lots of coal in this country. And so it was expected to continue going forward. And so these declines are both from a natural gas standpoint and renewables that are really taking that over. You can see nuclear's kind of stayed steady in terms of how much power it supplies in our electricity system. Just an exciting note, we're still very fossil fuel dominated, but renewables are growing quickly and provided a larger portion than nuclear coal for the first time in 2022. So we're seeing those transitions. Okay, another way to look at our system is called the Sankey diagram. Okay, so what is this giving you a sense of? This is our energy system, right? Our services, this is what humans want. This is the resource that provides them. It gives you a sense of what resources are providing which services and what is the efficiency of those services. So this is a chart that Lawrence Livermore National Laboratory puts out. And you can kind of see our renewables are all really electricity generation, as is coal. Natural gas is the diverse one. So natural gas is used for electricity. It's used for heating, cooking, things like that directly, both for water heating and space heating. And it's used for industrial processes. So it is kind of that diverse resource that's used lots of different ways. And then oil is very much transportation or industry to provide transportation fuels. So a lot of that energy is coming from our oil system. So it's just another way to look at it. I mentioned when we were looking at our coal system, right, about how inefficient our electricity generation system is. And so that big light gray area, the rejected energy, those are losses. So overall, this is just showing you that the energy efficiency of our economy is only about 33%. So that's how much is providing the services we want based on the energy that we're putting in. Let's talk about why we care about energy. So I just kind of summarized it here, right? These are what reasons you might be here to learn about energy. The economic reasons, costs and value. Political reasons, energy security and stability often comes up. Geopolitics. The environmental reasons, we talked already a little bit about climate change, but there's lots of other environmental reasons we care about energy. Ethical reasons, because energy is so important for human development, energy access and equity, and then medical reasons that we care about energy. Access to energy can really impact the availability of medical access, and then the impact on diseases. So lots of reasons we care about energy. So what I'm going to do next is really just go through a few of the examples of some of these reasons we care about energy. All right, first example, social costs equal private costs plus externalities. When we're talking about externalities, often we're talking about the things that society bears that aren't included in the private costs of whatever we're purchasing. So lots of examples of this. So social costs would be the total cost of those private costs that we spend, plus the externalities related to using that energy resource. So I put up this is just one example. So this is a fun little cartoon where he's pulling up to the gas station and it's like $1,000 a gallon. And so the person at the gas station is explaining, he's in his military gear, about how the gas is only, about $4 a gallon, but then all of the infrastructure and the military and everything to protect the access to the oil are externalities that's borne by society and not included in those private costs, right? And so that's just one example. A lot of times we think about, for other externalities, we're a lot of times thinking about air and water pollution, climate change, land use. Those are all externalities that are borne by society, often not included in private costs. So what do we do about this? How can we change this? That takes government, right? So government taxes, things like that, can try to incorporate some of those externalities into the private cost. I think the easiest one to think about is a carbon tax. A carbon tax would incorporate those costs on carbon into your private costs, right? That would be the idea of a carbon tax, is incorporating the impact on climate change of using a certain resource into your private costs. It takes regulation, it takes government action in order to change the markets to be able to include those externalities. And a lot of times that does not happen. I would say even in the oil example, a lot of times there's subsidies that almost move it in the other direction. We subsidize domestic production, for example, of oil because we're worried about energy security, not necessarily about the climate impacts of the oil, right? And so there are different policies that kind of push that private cost one way or the other, depending on what externalities you're worried about. Okay, so that's one reason we care. Another reason we care is, foreign policy, trade. Oil is a good example of this one too. Geopolitics. Our neighbor to the north, that's where that's our largest supplier for oil imports is Canada. Not the one we hear a lot about in terms of the news, because much of it's about Saudi Arabia, who really has an impact, and we'll talk more about this next week, really has an impact on oil price based on the markets and the type of oil that they have and the amount of oil they have. So they're often called the swing producer. They're able to turn off and on oil production really easily, and so they have a lot of influence on price. So you hear more about them, right? You hear about OPEC, you hear about Saudi Arabia. Canada is really our largest importer, and the second largest, which is more recent, is Mexico, our neighbors to the north and south. Okay, this landscape has changed a lot. So right now, we only import imports count for about 35% of our oil demand. So the rest of that is domestic oil production. And so we'll talk more about the horizontal drilling, hydraulic fracturing revolution that happened that really led to this change in oil production and crude oil production domestically, and how much we're getting domestically versus importing from out of the country. So it's a significant drop from 10 years ago when we were getting 2/3 of our oil from outside the United States. So that landscape has changed a lot. I often like to ask, okay, so geopolitics with Canada tends to be pretty friendly, nation with the United States. But what's a trade-off for that being a major source of oil for the U.S.? Anybody know about oil from Canada? Yeah, there's definitely a dependency. At least it has come down, but yes. Yeah, exactly. Heavy oil. So tar sands, oil sands, it's called different things. More environmentally impactful oil coming from Canada because it is access to strip mining. So you have to clear the land and dig it up, and it's a very energy-intensive process to get that oil. So from a geopolitics standpoint, it might be a positive, but from an environmental standpoint, it's more damaging. And so those are other aspects. So we'll talk about these in more detail as we go through the different resources. This is just like the preview and the highlights. Okay. One I think that has been very relevant on the global stage right now is Europe's natural gas dependence on Russia for natural gas, right? And this really became, I think, recently really part of the conversation when Russia invaded Ukraine. But that is not the first time that Russia has used this dependence to try to exert political pressure on the EU or on Ukraine. And so that's something that's been happening historically. And so I tried to give a sense of that. This is from 2001 to 2021, giving you some sense that there have been other times. Here's an example in 2009 that Russia has shut off natural gas supply to Ukraine or through Ukraine to the rest of Europe to try to exert political pressure. So this kind of dependence on other countries, especially if they're antagonistic or they have other agendas than your country, it can be really impactful on your politics and country relations because those energy resources are so important for our economies. In Europe, natural gas has been really important for heating in the winter, human services that we care about. And so since Russians invaded Ukraine, the EU has made a concerted effort to reduce its dependence on natural gas. And so some projects were shut down that were going to increase Europe's dependence on natural gas. And there's been a concerted effort to really switch to heat pumps, for example. So they're using electricity to heat homes rather than natural gas. So there's a lot of layers there, but this is one of the reasons we care, right? Is that dependence and how much that can influence foreign policy and politics. Another reason we care, global energy consumption is highly inequitable in our world. So this is just all of our commercial energy consumption. So this does not include traditional biomass for all the countries that it is tracked for, okay? And so I've tried to group them a little bit. So you can see United States, we've had a large portion of the world's energy consumption for a long time. Not a huge amount of growth in that energy consumption, but just to think about, we're 4% of the world's population. We're using 16% of the world's energy consumption today. China's had a lot of growth, but you can see, much bigger population, bigger energy demand today. You can see how that compares to places like Africa, which has 18% of the world's population, uses only 3% of the world's energy consumption. So it's highly inequitable. Why does that matter? It matters because energy is really important for human development. And so one way to look at that and that importance for human development is to look at the Human Development Index for different countries compared to their electricity use per capita. The reason they use electricity is because this is a modern form of energy. It can provide a lot of different services. Electricity is a high quality energy carrier that you can do a lot of things with. And so having access to that modern type of energy carrier can be really important for providing high quality human services. And so what this is showing you, you've got Human Development Index here on the y-axis. At the low end of human development, that access to modern energy carriers like electricity is really important for human development. You can see that just a little bit more access to electricity consumption per capita can really improve your Human Development Index. It's really important on the low end. And then when you get up to, that 0.8 is what they consider very high human development, kind of levels out. It's like there's a lot of variation in electricity consumption per capita, but that doesn't necessarily lead to a higher human development index. And so what is this telling you? It's telling you at the low end, they're really important. The high end, we could probably do better. We could probably have a similar human development index and use less electricity per capita. And so that's why it's important. It's inequitable. And it's really important for human health and human access. All right. As a summary, I just put together a lot of other environmental impacts that we care about for energy. And I want to give you the sense that these environmental impacts happen all along that energy system. It's not just the resource extraction, it's also the changing the resource into a carrier that is useful for us, like electricity, and then the use of those end services. They all have environmental impacts. And so it's that whole system. We'll talk a lot about the systems for all of these different resources. So they have, and I'm just going to throw these up here, we have land impacts, water impacts, atmosphere, of course, air pollution and climate change, wildlife impacts in terms of habitat and species, health and safety for humans, they have impacts there, annoyance, so just visual or noise impacts, and not just now or recent, they can have long-term impacts. The big ones that really come to mind, climate change is very intergenerational. Nuclear waste from our nuclear power plants, very big intergenerational problem. And then, of course, extinction is a forever thing. So those are long-term impacts that we can have from our energy use. And then environmental justice and equity is a big layer here. Is like, how are these different options for energy resources impacting environmental justice and equity? I'm going to give a few more environmental examples. I mentioned air pollution is very near and dear to me because it was very real for me growing up. So a lot of people don't realize how big an impact air pollution actually has on human health and mortality. So just to give you a sense, globally, air pollution is estimated to contribute to premature mortality for over 7 million people every year. 7 million people, so that is about the same as people that have died worldwide from COVID-19 so far. And that's every year. It is a big problem. And a lot of it is traditional biomass use, inside homes, so indoor air quality where a lot of people are. Particles getting into your lungs, premature mortality due to cardiovascular problems. Even in the United States, air pollution is estimated to prematurely kill 100,000 people a year. And there's different estimates. That's compared to 30,000 people die every year in car crashes in our country. It's a major problem. It's a major challenge. It is also not equally distributed on who is impacted by air pollution. So this is just a picture of a recent study, and there's this Harvard study that was done in 2017, looking at who's impacted by the air pollution and who benefits from the energy service that was provided that produced that energy, that air pollution. And so what you're seeing here is air pollution emitted. So in other words, you're getting the energy service from that air pollution emitted, much more for the white populations, and then the Black and Hispanic populations had much more impact from that air pollution. So it is inequitable about who is being impacted by the energy service and who is actually getting the energy service. So this is also another reason we care and why we have to do our systems better, is the inequity that exists in our energy systems, the way they are today. All right, I left one of the big ones, this big intergenerational ones, for last in terms of why we care, and that's climate change. Energy is the biggest contributor to climate change, our use of energy. And so that is impacting all of us, and it's impacting us today. It's not just an impact in the future, it's impacting us now. I have just some examples. We see fires, we see hurricanes, we see heat waves. Just this year, we got a record for average sea surface temperatures, so it's impacting our oceans and our ocean life in a big way. And then Canada saw an unprecedented fire season this year, which impacted not just Canada, but the East Coast with smoke, something we're familiar with here. And the wildfires in the last few years really impacting air quality in the Bay Area. So climate change is here. It is impacting us now. And we have very little time in order to meet goals like keeping climate change to 1.5 degrees globally. This transition needs to happen quickly. And so it is one of the reasons that we really care about our energy systems and how we're going to change them. to end on the positive note, let's talk about the energy transitions that we have happening and what we can do to lead us into a cleaner energy future. So for the last 10 minutes, I want to talk about how about a revolution? How about we do some different things? This was just like a study that was done is what would the investment look like in different sectors in order to really transition them to net zero carbon emissions by 2050. And so you can see different sectors, it's going to take a different amount of investment. And there are different levels of solutions. I think for the electricity system, we have a lot of solutions there. Transportation, some of those we're still figuring out. We haven't figured out air travel, how to really decarbonize that. Long distance travel, we're still figuring out that. There's still some technology that needs to happen, but there's a lot of work going on that. Buildings, we know a lot of solutions. This is really an implementation problem and how to do that. But decarbonizing some of the things like cement and steel that go into the building sector, that still needs to be worked out, right? And so there are different aspects of these different sectors, and there are different stages of solution in terms of what needs to happen. I think we foresee a lot of the challenges, and so there are ways to make an energy transition, trying to take those into account, and ways to do it poorly. And I think we're going to see a mix of that. So I think batteries are a great example, right? The resourcing for a lot of the materials for batteries where we're getting them today, have significant environmental and human and social impacts. And so I think a lot of people are aware of that. They know that. But they're trying to figure out a way forward that transitions to more responsible sourcing of those while still driving, towards batteries and electric cars and batteries for storage and things like that. And so a lot of that takes a lot of people thinking about it carefully. We talk in this class that there's no free lunch, right? Every resource we use has impacts. And so then it's just understanding what those impacts are and trying to mitigate them, because we can't get anything that doesn't have impact. We talk in one of my workshops about unintended consequences. It comes up a lot in policy, because you think you've figured it all out, and then there is something that's like, oh, I didn't realize that was going to make it do that. The big example I like to use is California has a low carbon fuel standard. And so what that goal is to try to lower the carbon intensity of our fuels in California. One of the things that meets our low carbon fuel standard is ethanol from Brazil, because it's made with sugarcane. It's a much less carbon intensive way of making ethanol than corn ethanol from the United States and the Corn Belt. So what do? We export ethanol to Brazil from the US and import ethanol from Brazil to here to meet the low carbon fuel standard, right? That's an unintended consequence. They were trying to think this out, but it leads to things like that. And so I think we just have to have flexible options to revisit and say, we didn't realize it was going to be this. Let's try to address it. But that takes collaboration and knowledge and an intent to do that. All right, so the best energy resource we have is providing services without using energy. So energy efficiency is where I like to start. And this is just an example of energy efficiency and how it works. So a man named Amory Lovins, who founded Rocky Mountain Institute, we are lucky enough to have him here at Stanford. He teaches in the winter and spring a class called Extreme Energy Efficiency. Highly recommend it. It's really about integrative design. It's really about how do I solve problems, thinking about what I want, the goal, the human service I want, and then optimizing the system to provide that service. So this is just to give you a sense. This is from his book, Natural Capitalism. That back in the 1970s, that blue line was what we thought we were going to need energy going into the future. That was the estimate from industry. That was the estimate from government. These are our energy needs. That's what we need to try to plan for the future. And Amory Lovins, who was kind of derided at the time because it was kind of an out there concept, he said, no, we're going to do it smarter than that. So he proposed that black line. He said, we're going to figure out ways to do it better, ways to provide the services we need without just increasing energy up and to the right. And so that red line is what we actually have done, much closer to that. And so energy efficiency is challenging, but it works. And I did some projects even when I was in industry. One that was just reusing some low temperature heat on another process instead of creating low temperature heat, and had like a 3-year payback, right? Energy efficiency works. It's all about providing those services we need, using less energy in the first place. It's the easiest way, the cheapest way to decarbonize. So this is a pretty famous curve that was done by McKinsey, looking at greenhouse gas abatement options. Many of these that are on this side that are actually, investment positive, you get your money back, are energy efficiency options. It's much easier to provide all of the human services we need to provide if we're doing so with efficient systems and using less energy to do them. Why is it so challenging? A quote from a former professor here at Yale Masters who worked in energy efficiency said, it's not $20, it's 2,000 pennies. It's hard because you have to plan every single system. A lot of it is you have to look at them individually. So it's a way of solving those problems. It makes it challenging, but it works. Lighting, I think, is a great example. An LED light bulb not only uses less energy, it doesn't give off heat, so it's better for space cooling. You don't have to change it as often, so you have less investment in materials. There's a lot of co-benefits for having a solution like that. So that is our first option. Next major revolution that's happening, right, is our renewables, our wind and solar. This is the United States. They are taking off. And they're taking off not just because we do have some subsidies at the government level and at state levels, but even on an unsubsidized level, wind and solar are the cheapest options for new electricity production. They're cheap, they're fast. In other words, you can put them up in a year or two. New nuclear power plant, new coal-fired power plant might take a decade or two, right, with planning. Fast and cheap. So they're competing on a market basis. That's why they're taking off. Last year, over half of the new electricity additions in the United States were wind and solar. So this is an area that we're seeing a lot of growth. Transportation, near and dear to me. There's a lot of inefficiencies in transportation. We inefficiently use our cars, so it's a big capital investment that we use very little of the time. It's mostly parked for most of its life. Very inefficient motive power. We talked about this. Only about 1% of the energy you put into it is actually moving you around. And even the system, the roads and stuff, we use them pretty inefficiently. We have a lot of empty roads. That's a lot of investment. And so there are innovations that are happening in all three of these areas that can make these systems more efficient. Because again, what is it really about? Moving us around and moving goods around. And so how do we optimize those systems to do that more efficiently? I get excited about electrification despite some of the challenges that we're going to talk about because it is so much more efficient and because even with our current electricity system, it is a much lower carbon option. So this is a chart. You can each go and look at each individual state if you want to see where your state stacks up. Looking at what are the emissions from different vehicle options in terms of carbon dioxide emissions based on that state's electricity mix. So this is just the national average. Electric cars are taking off in a lot of countries. Norway, notably, because they have a lot of incentives for people to buy electric cars versus other things. There are a lot of countries that even have said 2030, 2035, things like that. We are going to only allow zero-emission vehicles to be sold. There's a lot of change happening. Big market is China for electric vehicles. So a lot of growth happening in this area. And then batteries. Batteries are exciting. They're not the biggest way we store electricity right now, but there's a lot of potential for batteries. It's definitely a growing area. And I mentioned that wind and solar are the cheapest, but now even wind plus batteries or solar plus battery can come in cheaper than existing coal and nuclear. And so that market paradigm is really driving not just the wind and solar, but storage options as well, and is leading to this integration. The first time we're really going to integrate these very separate things of our electricity system, our homes, and our transportation. This is all going to be integrated. We see green buildings. I'll just flip through these. Geothermal is a resource that is coming on quickly. Hydrogen's getting a lot of attention, so we'll talk more about geothermal and hydrogen. Fusion, which we'll go on a field trip to learn more about. Carbon capture and storage, which is seen at least as a small portion of the solution. All of these are transitions that are happening, and we'll learn more about this quarter. So thank you for your attention.